In this video, we'll be taking the understanding of limits a step further and looking at limits visually, graphically, and using a table. Let's say we want to consider the function f of x equals x squared minus 4 over x minus 2, and we want to analyze its behavior as x approaches 2. To do this, we have to approach 2 from both the left and the right hand side. So as you can see, as x approaches 2 from the left, f of x seems to be approaching 4. And we can see that because from 1.9, 1.99, and so on and so forth, we're going from 3.9 to 3.99, and so on and so forth, and we can safely assume that it's approaching 4. From the right-hand side, as x is approaching 2 from the right, we can see that f of x is also approaching 4. Now remember, a limit only exists if the one-sided limits are equivalent to each other. And whatever the one-sided limits evaluate to, that's also the answer of the limit. So that means that we can see the limit of, as x approaches 2 from the left, seems to be reaching 4 of f of x. And the limit as x approaches 2 from the right is also safe to assume 4 of f of x. Now we can safely say that the limit as x approaches 2 of f of x is equivalent to 4. Now this does not mean that f of 2 is equivalent to 4. As you can see, if we were to plug in f of 2, we can see that in the denominator it would be 0, and therefore f of x would be undefined. Now it's crucial to make this distinction because a limit is just what f of x is approaching as x approaches, in this case, 2. Whether or not there is a value defined at x equals 2 has no bearing on whether or not that limit exists, meaning it doesn't affect whether or not the limit exists. In this case, we can see f of 2 does not exist, but the limit as x approaches 2 of f of x exists, and it's equivalent to 4. Okay, moving on, let's look at it graphically, which is another way of solving this problem. We can see that it is a linear graph and has a hole at 2, 4. And from here, we can say that the limit of f of x as x approaches 2 is equivalent to 4. Again, although f of 2 is not defined for f of x, that does not mean that the limit doesn't exist. All right? So limits do not care whether or not the function is defined at that specified x value, in this case 2. What they care about is the left and the right side of the function approaching 4, meaning is f of x approaching 4 as x is approaching 2? And the answer is yes. We can see from the left-hand side it's approaching 4, and from the right-hand side it's also approaching 4. I hope this video made sense. Please comment down below any other my topics for me to review. Thank you.